Thank you for tuning into tonight's Sea Week Ngā Kōrero event, Pacific Paradise in Peril. It's our 5th webinar, and tonight we put the spotlight on climate change and the relationship between the ocean and a changing climate. I'm Alison Balance. I'm your MC for the evening. I'm a natural history writer, a broadcaster, a beach walker, a diver, and a very big fan of the very big blue Pacific Ocean. With me, virtually, 2 from New Zealand and 1 beaming in from Samoa, we have 3 fabulous guests, Philomena Nelson, Tim Naish, and James Renwick. We'll be hearing from them very soon. But first, we'll kick off with our usual karakia. Tukoe te wairua kia reri ki ngā taumata. Hei arahi a tātou mahi. Me tā tātou whai I ngā tikanga a rātou mā. Kia mau, kia ita, kia kore ai e ngaro, kia pupuri, kia whakamoa, kia tina, hui e, taiki e. Allow one spirit to exercise its potential, to guide us in our work as well as in our pursuit of our ancestral traditions. Take hold and preserve it, ensure it is never lost. Hold fast, secure it, draw together, affirm. Kia ora, everybody. If you are new to this, a very big hello. If you've joined us before, you'll know how this works. We'd love for you to introduce yourselves to us in the chat. We always like knowing where you are tuning in from. You can find the chat box via the text bubble icon at the bottom of your screen, and it should bring up the chat panel on the right-hand side. Feel free to chat away amongst yourselves. Now, a bit of background about Sea Week Kaupapa Moana. It's New Zealand's annual national week celebrating the sea, Te Moana. While Sea Week's pinnacle of physical events has actually already occurred at the beginning of March, Sea Week has a year-round mission which is about exciting and inspiring all New Zealanders to renew their connections with the sea, which is why Sea Week is hosting this Ngā Kōrero webinar series exploring ocean kaitiakitanga in Aotearoa, New Zealand. Ngā Kōrero is designed to foster better communication about various ocean-related topics. This webinar series is highlighting the diverse connections and interactions that we all have with the sea, reminding us that our daily lives are intertwined with the health of our ocean environment. This is an opportunity for people from all over New Zealand to engage with us, to learn about our impact on the environment and the actions we can take to safeguard the ocean. We'd like to say a very big thank you to our longtime supporters of Sea Week, and in particular, those that have made this webinar series possible, the New Zealand National Commission for UNESCO and the Live Ocean Foundation. Thank you. Let's reflect for a minute on what we've looked at in previous webinars. We started off with From the Rivers to the Sea, which was a look at estuaries and the downstream legacy of things like sediments and nutrient pollution. We looked at preserving kai moana, fishes for the future. Microplastics, which turn out to be an enormous problem for a very small thing. And we've marveled at marine megafauna, international travelers of the big blue, dealing with all sorts of issues on their journeys. If you've missed any of these previous sessions, they are all recorded and available for you to watch at any time on the Sea Week YouTube channel, the Sea Week website, or their Facebook page. Look in the videos section there. This section is also being recorded, so you can come back later and watch again, or share it with others so that they can watch it later. And just so that you've got your evening nicely planned, we plan to finish by 8:30, and we're pretty good at finishing on time. So tonight's topic, climate change, a complex issue and an urgent issue. Our experts are going to shine a light on where we are now with climate change impacts in Aotearoa and the implications for the wider Pacific. We'll cover things like the ocean's role in absorbing carbon dioxide and heat, and the effect of warming on everything from ice sheets to marine species. And before we wrap up, we'll be talking about climate action. How can we all play a part in reducing emissions and stopping warming? This is all very topical, by the way. The World Meteorological Organization put out a new report just yesterday. I saw it last night on the RNZ website, for instance, and our ocean is changing and changing very fast. We'll be hearing about that and much more from tonight's amazing lineup. Let me introduce our three speakers. First of all, we're going to hear from Dr. James Renwick. James is a professor at Victoria University of Wellington, Te Herenga, Waka. James is a climate researcher who studies Southern Hemisphere climate variability and the impacts of climate change on the Pacific, New Zealand, and the Antarctic. Next up will be Dr. Timothy Naish. Tim is an earth science professor at Victoria University of Wellington, Te Herenga, Waka, and he's seconded part-time to Antarctica, New Zealand, leading the Ice Ocean Atmosphere program. Our final speaker will be Philomena Nelson. Since October 2017, she's been the Climate Change Adaptation Advisor at the Secretariat of the Pacific Regional Environment Program, more commonly known as SPREP, and she's based in Samoa. After each speaker has presented, I'll ask them your questions. And remember, you can send us your questions at any time using the Q&A function, which is also on the bottom of your screen, somewhere near the chat function. So throw your questions in at any time they occur to you. If you've got them for a particular speaker, let us know who you'd like me to ask. Otherwise, we'll just see who answers your question come the time. So fire away those questions. We'll get to them at the very end of the 3 sessions. So, ta-da, to start us off, we have Dr. Renwick. James has been a lead author for the Intergovernmental Panel on Climate Change, IPCC, for the last 20 years. He's contributed to 3 assessment reports, as well as his academic position at Victoria University, Te Herenga, Waka. He's a commissioner at the New Zealand Climate Change Commission. James is going to set the scene for us. So take it away, James.
Well, kia ora koutou, and thank you very much, Alison, for that introduction, setting the scene. So yes, I'm first up. I shall just share my screen. Where are we here? And get that going. Okay. So my presentation is on, as you've already heard, climate change and what it means for our Pacific paradise. I'll be focusing mostly on the oceans, as it's a Sea Week presentation, but happy to discuss sort of more general aspects of climate change. Anyway, let's get right into it. And hold on, I'm just going to check time here. Okay, very good. So, where are we at with climate change? Well, I'm about to show you my favourite diagram that explains this. And here it is. It's how the amount of carbon dioxide in the atmosphere has changed over the last 13,000 years. Now, carbon dioxide is really the problem child with climate change. It's a very effective greenhouse gas. That means it absorbs the heat the Earth radiates out to space, holds some of it back down, warming the Earth's surface. And it stays in the air for hundreds and hundreds of years. That's one of the main reasons it's a big problem. It just builds up as you add it to the atmosphere. So what we see on this graph here, we've got time along the bottom axis, starting at 11,000 BC, going through to the present. And the vertical scale is the amount of carbon dioxide in the atmosphere in parts per million. It's a real trace gas. It's only there as a fraction of a percent, but it's a very important fraction. So what we see is over this 10,000 years or so coming out of the last ice age, carbon dioxide amount rises up to the pre-industrial level of 280 parts per million. And then in the 1700s, people started burning coal initially to power steam engines. This was the beginning of the Industrial Revolution. And so that created carbon dioxide that was put into the atmosphere, and it's still there, basically. So over the last 200 and something years, we've added more and more of this stuff to the atmosphere. And so it's built up and up and up. And we're nearly 50% above the pre-industrial level now. And that change has happened in not much more than a couple of hundred years. So the Earth operates on this sort of timescale, 10,000 years or longer. That's usually how long it takes for these gases to go up and down in the air. And it's how long it takes for ice sheets in the deep ocean to respond to the sort of changes that have come around as a result of changing the chemistry of the atmosphere like this. But over time, we've become better and better and better at adding this stuff to the air. So we've had nearly a 50% rise in the last 260 odd years from the pre-industrial value. But the first half of that rise took about 230 years to achieve, while the second half of the rise has only taken about 30 years to achieve. So compared to the original few decades of all of this, we're really pumping the stuff into the atmosphere super fast these days. And we're now at a point where the total amount of carbon dioxide in the air is as high as it's been for about 3 million years or so. So we're breathing an atmosphere that hasn't been seen on the Earth since before our species evolved. It's very much uncharted territory that we're in already. Anyway, putting this carbon dioxide, and there are other greenhouse gases obviously, into the air, increasing those, that's like putting a thicker blanket over your bed at night. It keeps what's underneath warmer, and in this case the surface of the Earth has to warm up as you add these gases to the air. And that's exactly what we see. If you look at global temperatures, here's a graphic of annual average temperature change over the last 140 years, going back to 1880 at the beginning of this time series, through to 2021 as the last bar on the graph. And the vertical scale here is temperature in degrees C. The zero line is the average temperature globally before 1900. So this is about as close as we're going to get to an estimate of the actual pre-industrial temperature. So compared to that zero line, you can see we're up here, 2021 as the last bar. The last 7 years have all been more than a degree above the pre-industrial value. So we're averaging at around 1.1 degrees or so above pre-industrial. And you can see there's plenty of ups and downs. There didn't seem to be a lot happening until around the middle of the 20th century. And then you see this really clear upward trend. And remember, we're pumping so much more greenhouse gas into the air, so much faster now than we used to. It's no surprise that we see this really clear trend come through in the last 60 or 70 years or so. And the top of the scale on this graph is 1.5 degrees. And that's if you're familiar with the Paris Agreement, which all the countries of the world have signed up to, that says that we'll do what we can to limit warming to 2 degrees, no more than 2 degrees above pre-industrial, and we'll try hard to limit it to 1.5 degrees. And in this country, the Zero Carbon Act mandates that New Zealand will play its part in the global community to limit warming to 1.5 degrees. So pretty obvious there's not a lot of room there between. We've already had some years at about 1.25 degrees above pre-industrial. We don't have long to wait to get to 1.5 unless we take some pretty serious action pretty soon. So that's what's happening in the air around us. It's what we experience, this warming, and that goes along, of course, with big increases in the intensity and the frequency of heat waves, droughts, floods, fires. A lot of extreme events ramp up as you pump up the temperatures. But what we see in the air, the change in temperature in the air, is actually only a tiny fraction of the story. Most of the heat is actually going into the ocean. So here's another graph. I just love graphs, quite a few of them in this presentation, I'm sorry. This is a graph of how the total amount of heat in the top half of the global oceans, the top 2,000 meters, has changed since the late 1950s. So we've got time along the bottom again from 1957, 58, I think is the first point, through to the end of 2021. And the vertical scale here is the amount of heat in the global ocean, or the top 2,000 meters of the global ocean, in joules. And joules times 10 to the power of 22. That's a 1 with 22 zeros on the end. We're talking a large amount of energy here, a really large amount of energy. And we've gone from somewhere like -5 or a bit less than that on the scale, where 0 is the average in the sort of 70s to 1990, I think it is. And we're up getting close to 30 on the scale. So we've had about a 35 unit increase in the amount of energy. And just to try and put that in a bit of context, that amount of energy, which is it's 350 billion trillion joules, It's about 700 years of total human energy use in today's numbers. So it's a truckload of energy that we're pumping into the oceans. And of course, that's changing the circulation of the oceans. It's changing the depth of the oceans. You'll hear from Tim about that. And it's changing everything to do with how the ocean operates and the things that live in the ocean, of course. So over 90% of the warming we get from adding these greenhouse gases to the air is going into the oceans. So the good news for us is that it slows the rate of change that we experience. If all of this amount of heat was going into the air, temperatures would already have gone up something like 40 degrees. We'd all be dead. We wouldn't be having this conversation. So it does slow down the experience we have, how quickly the climate on land changes. But the downside, I suppose, or one of the downsides is that the ocean's very slow to respond. So we've locked in change in the climate for hundreds of years to come as the ocean expands and the currents adjust and so on. So it slows down the rate of climate change, but it also extends the period over which the climate's going to change. And one of the things that happens when you warm the ocean this much is, just like on land, you see more extreme events, more high temperature extremes in particular. And something that's come along in recent years, I didn't hear about this 15 or 20 years ago, this idea of marine heat waves. So these are periods where a certain patch of the global ocean becomes a lot warmer than it would normally be. And this map here from a recent paper shows some of the significant marine heat wave events in the last 10 years or so. And the Tasman Sea is featured. There've been a couple of big marine heat waves, in particular one in 2017, where the oceans around Aotearoa and to the west of us became a lot warmer than normal. You can see the temperature scale on the right there, 3 degrees or so warmer than average. So this is a big deal for this part of the world, and it's a big deal for the whole world, actually, because the oceans are getting warmer pretty much everywhere. If you look at the globally average number of days of MHWs, marine heat waves, here's what it looks like going right back to 1900. You can see that sort of bouncing around, but 30 odd days a year was pretty typical. And then this century, things have really started to accelerate up. And in recent years, we've been getting close to 100 days per year. So I don't know, that's a bit of a spike, but I'd say that 30 days a year is now more like 60 or 70 days a year. There's been already something like a doubling in the occurrence of these marine heat waves. And of course, extreme temperatures in the ocean are bad news for ocean life, just like extreme temperatures on land are bad news for life on land. If we look again locally, at the moment, we're actually having another marine heat wave event around this country. And the Met Ocean site, or the Moana project, so-called, has a really nice set of maps of what's happening with ocean temperatures and so on. And they have a marine heat wave forecast service. So this is a map for today, very fine detail, sea temperatures, the difference from normal. So you can see the colour scale here. And you can see around the country, most of the country, temperatures are at least a couple of degrees warmer than average, and quite a lot warmer than normal around most of the country. So you can get a map or a time series of how the heat wave conditions in the ocean are changing. And these two here for these boxes off Fiordland and around Rakiura, Stewart Island. And you can see on the graph here, so this is time now in days. The dashed blue line is the average temperature for the time of year in the ocean in that region, and the vertical scale here is temperature, sea surface temperature. And the green dashed line is the sort of threshold above which you are now officially in a marine heat wave. And you can see for Fiordland, the marine heat wave started back in April sometime. It's already been going for several weeks. Same story, Stewart Island maybe started a little bit later, but we're getting into moderate conditions off Fiordland and forecast to go into strong conditions in the next few days off Stewart Island. So we're seeing these events much more commonly in this part of the world and around the world as the ocean heat content and ocean temperatures rise. So moving on to ocean acidification, this is the other main issue with what's happening in the oceans. So what's happening is human activity, burning of fossil fuels mostly, is adding carbon dioxide to the atmosphere, and about a quarter of that carbon dioxide is absorbed directly into the oceans. The problem is that when you absorb carbon dioxide into the ocean, it forms acid, carbonic acid, and it goes through various chemical reactions. And what happens is the ocean water becomes less alkaline, a bit more acidic, and the concentration of carbonates in the water goes down. And carbonates are what shellfish and some forms of plankton use to build their little shells. So if you start taking that away, it becomes harder for especially creatures that use carbonate shells to form and grow properly. So it really literally eats away at some forms of marine life. So the latest IPCC, the Intergovernmental Panel on Climate Change report, had a lot of information on this. Chapter 5, this is a map of different parts of the ocean, and the graphs here all show a time series since the 1980s of change in the pH. This is the concentration of hydrogen ions in the ocean. It's a measure of acidity, basically. And you can see it everywhere you look around the world. All of these graphs are trending downwards. That means the oceans are becoming more acidic or less alkaline, I guess, everywhere you look. Another way of looking at it is to look through depth, another figure from the IPCC report. So this is looking along these lines across the Arctic Ocean, through the Pacific, through the Atlantic and the Indian Ocean, all of the major oceans of the world. And you can see them are sort of all strung out along the bottom here. And the colours show the change in the pH. So how quickly or how much has the ocean become more acid in different places. And you can see most of the change is concentrated near the surface of the ocean because that's where the carbon dioxide is being absorbed. But it's penetrating down several hundred metres, that's the vertical scale here, in a lot of places, not everywhere, but in a lot of places we're down to several hundred metres, maybe even 1 kilometre below the surface. So yeah, this will go on for a long time again as the ocean adjusts to all of this. And of course, you know, more extreme temperatures and more acidic conditions is not good for life in the oceans. That's no surprise. So in terms of marine life, the Great Barrier Reef has had some serious bleaching events in recent years. So this is where the coral basically, goes into a state of shock or possibly dies off for a while the temperatures are very high. It can recover, but with enough of these events, quickly enough and more intense events, the coral can actually die off completely. And the estimate is that if we get to 2 degrees of warming above pre-industrial levels, then basically all tropical corals around the world will be dead. Whereas if we can stop the warming at 1.5 degrees, we can save about 30% of them. It's still not great, but better. And more locally, here's a figure that was in the news just this week. Some pictures of native sea sponges on the coast of Fiordland, and you can see it said in the Radio New Zealand report that scientists were shocked by this. A couple of Victoria University marine ecologists took these photographs. Normally you have these lovely brown sponges and they've been completely bleached and basically have been killed off because of this marine heatwave event that's happening at the moment. So we'll see more and more of this as things warm up more. So where are we going with all this? You know, what's going to happen? Just to go back to my favourite diagram, the basic idea is the higher that spike in carbon dioxide gets, the more warming and the more damage. So we have to stop that spike going up. We know that this much carbon dioxide gives us about 1.1 degrees of warming. That's where we are at the moment. And it's quite easy to work out at current rates of emissions how long it would take to get to other levels of warming. So we know that at current rates, we'll be at 1.5 degrees in about 10 years. 2 degrees would come about 10 years after that again. 3 degrees would come another 30 or so years after that. And, you know, by the time we get to these levels, we're really causing serious catastrophic changes and extremes and sea level rise, all the rest of it. So we really don't want to go there. We don't have a lot of time. But if we can reduce emissions of carbon dioxide by half this decade and get to zero emissions by 2050, that would add up to about the same amount of total carbon dioxide increase as just doing nothing for 10 years. So if the world can get on top of its emissions and decarbonise the global economy fast enough, we can still stop the warming at a level that is hopefully manageable, at least in a large part of the world. Onto the marine heat waves, that graph I showed before, and again, looking at the future, it depends on how quickly we reduce emissions. But, you know, we're talking about the number of heat wave days globally average going up to somewhere between 150 or to 300 days. So, you know, we're talking about it could become just the average conditions in a lot of parts of the world if we let the warming go on beyond 2 degrees. But if we're lucky, we could stop it, you know, not too much more catastrophic than where we are now. And with ocean acidification, just a quick graph. So this is time out to the end of the century, and the units of, well, it's pH again, the concentration of hydrogen ions in the ocean. You can see it's been going down in the past, and then there are various futures depending on how quickly we reduce our emissions. The green one is where we reduce emissions in line with 1.5 degrees of warming, and the red and the brownish lines are where we do the opposite. We just burn more and more coal especially, and just pump up the volume with the carbon dioxide. So I'd say the green line, the higher lines are recovery. You know, the pH starts to recover before the end of the century, whereas the red and the brownie lines I would call disaster. You know, the levels of acidification in the ocean would be something that hasn't been seen for millions of years, and it would be bad news for a large amount of ocean life, let alone life on land. Okay, just to wrap up, so what do we do about all this? We'll talk about this a bit later, I think, but basically we have to stop burning fossil fuels. So everyone can make a difference, and anything that you can do to make a difference makes a difference. You know, you ride a bike instead of driving your car, you buy clothes that last longer, so you're not constantly out there shopping for new trousers or whatever. Take public transport more. Buy an EV if you can afford one. Put solar panels on your home, etc. Find ways to reduce the amount of energy that you use, and think about how that energy is created, whether it's through renewable sources or fossil fuels. And I think a crucial thing everyone can do is talk about this problem, what we're doing right now. The more people talk about it, the more they know about it, the more they care about it, the more likely they are to you know, do something about it. But I think it's really important to know that it's a global problem. It's at the level of societies and countries and globally that we need these changes. So governments have to change how economies operate around the world, and they have to steer businesses in the right direction. So it's really important to get active, help the government to see what to do, make sure that you're rattling the cage with your MP and those people in power, so they feel empowered to push through legislation that will move us in the right direction. And I think another thing we all need to do is to cooperate with each other, with our own whānau, with our workmates, our neighbours, and between countries, both within the country, between regions, but also internationally. We need all the ideas we can get and all the cooperation that we can possibly get. And if you have the chance and there's a march on Parliament, do it. You know, the more voices that are heard in these kind of events. This is a picture of a march on Parliament in 2019, I think. Thousands of people converged on the lawn in front of the Beehive and Parliament buildings, and I think that kind of thing really carries a lot of weight. Anyway, I think I've gone on more than long enough. So we're already in a different climate. Temperatures have gone up higher than they have been already for thousands of years, tens of thousands of years perhaps. And everything's changing. Temperatures are rising, climates are changing, more extreme conditions both on land, in the air and in the oceans. On top of that, the oceans are becoming more acidic or less alkaline, whichever way you want to put it. And that's not good news for ecosystems everywhere. So there's no magic numbers here, but the idea is the greater the warming we have, the more extreme things become, the more damage that's done. And roughly speaking, stabilising temperature rise at 1.5 degrees would be hopefully manageable in a lot of parts of the globe. More than 2 degrees of warming, I think, would become very hard to cope with, very damaging, very dangerous for communities everywhere. The good news, I think, is that future change is dependent on our emissions, our actions. We have 100% of the power here. We're doing this to ourselves. We just need to stop doing it. The sooner we stop emitting, the sooner we stop climate change. So let's get out there and stop emitting greenhouse gases. Thank you very much. And I shall stop sharing. There we go.
Ka pai, kia ora, and thank you, James. That was very sobering, I have to say. I was in Fiordland and Dusky Sound a few weeks ago, and I was swimming, and it was disconcertingly balmy, and there was a boat there that told us the water was 21 degrees and that it had been like that for weeks. And wow. I am appalled to discover that it's still warm down there. It's just, it shouldn't be like that. And I do remember actually seeing you, James and Tim, at that big climate march on Parliament. You were, I think, wearing T-shirts that said "Ask a Scientist." So good on you for being there.
Yeah,
anyway,
and I think, I didn't say it, but the heat wave off Fiordland, by some measures, is the strongest that we've seen in the record of sea temperatures. So yeah, things are just getting worse, I'm afraid.
Yeah, it should not be 21 degrees in Fiordland, especially not in April. Anyway.
No.
Anyway, our lovely listeners out there, don't forget, any questions, ask away in the Q&A, and we'll ask them after all the speakers are presented. Now it's time for some more probably sobering science from Dr. Naish. Tim Naish's research focuses on climate change, with specific emphasis on how the Antarctic ice sheets respond and how they influence global sea level. He has also contributed to IPCC assessments, and he co-leads the New Zealand Sea Rise program, which has featured in the news quite a lot recently. Tim, over to you.
Ngā mihi, Alison, kia ora koutou, and yeah, thanks James for setting the scene so nicely. Okay, I'll just share my screen and we'll get right into it. So just tell me, Alison, if it's not doing what it should be doing. Are you seeing my slideshow? Great, and if I go to full screen, how's that looking?
That looks fantastic, take it away.
Awesome, great, let's go. Okay, you can see the theme here. Sea level is rising and people are getting flooded in the Pacific and in New Zealand. And yes, Alison, yeah, as she says, we definitely had some media over the last few weeks because we released a new set of sea level projections for New Zealand. And these take into account local factors, and local factors matter a lot for New Zealand. So what I'd like to do is quickly go back to Antarctica and just talk about why that is such a problem when it comes to estimating sea level rise. We'll talk about the implications and impacts for New Zealand, and then I'll delve into some work that's happening in the Pacific Islands. But bearing in mind, Philomena will follow up with more detail on that. So this, you can see in the center of our screen here, we can see one of the new sea level projections from the New Zealand Sea Rise website. And this is a point just right next to Pipitea campus. James and I were involved in this photo on the bottom right here, which was part of a campaign that Victoria University were running to raise the awareness that, you know, sea level rise is coming. And I must admit, I was sitting here or standing here with my daughter who graduated on Tuesday. And we were all marching from this point on Pipitea campus down Lambton Quay. So, you know, this is the situation we're facing. You know, this towards the end of the century, and I'll come back to some of that. But yes, one of the clearest consequences around the globe from the warming that James has talked about, from the carbon dioxide that's gone into the atmosphere, and from the temperature response to that, is global sea level rise. And this graph is a global average summary of what's happened since the Industrial Revolution, 20 centimeters of sea level rise, and an acceleration in the last 30 or 40 years, and you can see 12 centimeters or so since 1990. So sea level is rising, it is accelerating in the rate of rise, and it will continue to rise for centuries to come. Now, 20 centimeters might not sound a lot, and it isn't a lot, it's the height of my hand. It doesn't seem very much, but when you put a storm on top of that, when you put a large storm on top of that, it has an exponentially bigger impact on us. And there are examples from Bangladesh we can talk about, Bay of Bengal, but also Western example would be Hurricane Sandy. Without that 20 centimeters of sea level rise, they would have saved about $3 billion on damage that occurred with that big hurricane event, that storm surge that hit Manhattan Island. Okay, sea level rise, complicated thing, but I want to break it right down. There's a few figures here, cartoons. When we talk about global sea level rise, there's three things that matter. One is the polar ice sheets, Antarctica and Greenland, which are melting, and they've provided a third of the observed sea level rise we've seen so far. The other is what James introduced to us, the heat that's gone into the ocean. That has led to a third of the sea level rise, because we all know when you heat water, it expands, and so the sea surface is rising. And the other one is the glaciers on the mid and low latitudes. So they are contributing in equal thirds to the observed sea level rise we've seen so far. The polar ice sheets are now getting into the driver's seat and are beginning to dominate. And they're a concern because there's a lot of water locked up as ice that can melt and go into our oceans and create sea level rise in the future. There are other things that matter to a certain extent, but for New Zealand, geodynamic processes matter. And, it won't be lost on any of you that we live on a very active plate boundary. We have the Southern Alps going up, we have the Pacific plate crashing into the Australia plate, we get earthquakes, parts of New Zealand are going up and parts of New Zealand are going down. And you have to take that into account, as well as the global sea level rise when it comes to estimating at your place, at a point on the coast near you, what sea level rise will do. Let me just digress into Antarctica very quickly. This remains one of the biggest issues and uncertainties when it comes to predicting global sea level rise. The ice sheet is massive. It's got 60 meters of potential sea level rise. It isn't all going to be melted and released into the ocean in the next decade, century, or even few thousand years, but it's certainly starting to happen. And it's starting to happen in these areas. If you, on the right here, if you take the ice sheet off and you look underneath it, the Antarctic ice sheet, you can see West Antarctica here is sitting below sea level, and so are large parts of East Antarctica. Now, James has talked about the heat that's gone into the ocean, majority of that into the Southern Ocean, and that heat is now getting up around the Antarctic ice sheet, and those bits that sit below sea level are incredibly vulnerable to that ocean heat, and they're essentially melting from underneath. And we're starting to see this accelerated loss of ice from West Antarctica. If all the regions of the Antarctic ice sheet that sit below sea level get attacked by warm ocean water and go, that's 20 meters of global sea level rise. Again, starting to happen now, starting to accelerate, but would take centuries to millennia for that whole 20 meters to happen. So what I'm going to do here is I'm going to run you a model that includes some processes we think are important for the Antarctic ice sheet. And as a consequence, these processes produce some quite rapid rates of sea level rise for the future, particularly if we don't mitigate our greenhouse gas emissions. So the Paris Agreement is incredibly important, and you'll see that. As James was saying, mitigate, mitigate. And I'm going to show you a little animation below, which is if we achieve the Paris target. I'm going to show you one above, which is if we have unabated emissions and global warming. And you'll see the difference to the Antarctic ice sheet. So note, we're starting in 1950. And we're about, I'll just kick these off. The top one, the bottom one, you'll see the clock ticking. You can see up top, you know, we're getting towards the mid-century. Things are starting to move. We're getting towards the end of the century, and look, we've lost the Ross Ice Shelf, we've lost ice shelves in the Weddell Sea, and we've lost the Pine Island Doomsday Glacier, and we've lost the West Antarctic ice sheet within 300 years. But below here, we're looking okay. We've pretty much maintained the ice sheet. We've lost a bit of ice in the Ross Sea and the Weddell Sea. And when we, you know, move into the centuries into the future, we appear to have avoided major meltdown of the Antarctic ice sheet. So there's an issue here. The IPCC, when they made their sea level predictions, gave one prediction, which said, you cannot rule out 2 meters of sea level rise globally if Antarctica does what it's does something really dramatic, like in the upper model here. However, it also says if we mitigate and we follow the Paris future, we have very little sea level rise. So what you're really seeing on the right-hand side is a couple of graphs into the future. The black line is Paris. The blue line is the trajectory we're on. You know, if you add up all the pledges at the latest COP26 in Glasgow, that is the future we're heading on if our governments deliver on their good promises. And so, you know, we're already not achieving that 1.5 that James talked about. That's very, very difficult. The 2 degrees of global warming is looking very difficult. And if we deliver on Paris, we're sort of on that blue curve. You know, and that's not great. That's 0.5 meter of sea level rise from Antarctica by the end of the century, you know, if these processes play out. And it's 16 meters of sea level rise from Antarctica by 2500, if we go through this tipping point. So Paris is incredibly important. Now, I want to just come back to New Zealand, and Alison, give me a nod when I've gone a bit long. But I think I've got 5 or 10 minutes to go. This is what the government is telling local government planners and decision makers to plan for. And this is in the current guidance, and it's one number, it's one set of graphs for the whole of New Zealand. And you can see that by 2100, we should be planning for perhaps 1.2 meters of sea level rise. This red line includes a bit of rapid action from Antarctica. This green line down the bottom is the best we can hope for if we achieve the Paris Agreement. And I want you to notice that by 2050, 2060, we're going to have 30 to 40 centimeters of sea level rise. That sort of can't be avoided. That's baked in. But beyond that, we have a range of futures depending on what the polar ice sheets do. Now, for New Zealand, there's an added wrinkle we have to take care of and when we do our sea level projections, and that's the fact that our land goes up and our land goes down. And when our land goes up, it actually is a good thing, because if you live where the land is going up, it actually reduces the amount of sea level rise because the land is keeping up with sea level rise. But if you live in places like Auckland and Wellington, the land is going down, and it's going down in some places at the same rate sea level is rising. So it doubles the speed at which sea level is rising. Now, we know what the land is doing. It's been an absolute game changer. We have these satellites that can measure exactly what the land surface is doing every sort of, 20, 50 meters around our coastline. We have continuous GPS from GNS's GeoNet network that is also very accurate, that we can calibrate the land movement to. And the bottom line is we can produce for the whole of the New Zealand coastline, and we have done this, an estimate of vertical land movement. So the blue colours are where the land is going down, and the yellow and red colours is where the land is going up. And this is over this time period. Now, you can see there's only very few places, and mainly the Bay of Plenty here, where the land is going up. For the majority of New Zealand, particularly the lower North Island, the land is going down. A big surprise is Auckland is subsiding. And of course, not a surprise, but the Marlborough-Nelson down to Kaikoura region is subsiding as well. So in these areas, and here's a blow up on Wellington, the land is going down at up to 5 millimetres per year. On the Wairarapa coast, it's going down at 8 millimetres per year. Sea level is rising at 3.5 millimetres per year. So it really makes a big difference to the actual sea level rise we will get. And a way of showing that is this graph, and this is for Petone Beach in Wellington. And in this graph, we're showing you a 100-year planning timeframe. If you're building a wharf, if you're building coastal infrastructure, roads, if you're building an airport near the coast, you are thinking on a 100-year timeframe. And so what we're showing here is that 30 centimetres of sea level rise is a really important threshold. For 30 centimetres of sea level rise, the 100-year flood becomes a once-in-a-year event. So the big floods that cause damage to the south coast of Wellington, to Auckland, to parts of New Zealand that come, the coastal floods from the big storm surges, happen with 30 centimetres of sea level rise every year. So in Petone, you would have thought, based on the previous information, that you had 50 years before that happened. But because the land is sinking, you barely have 20 years before that 100-year flood becomes an annual event. That's going to have major implications for the Wellington region and around Auckland. So, this is a big flood that hit the Firth of Thames in 2018. The road from Thames to Coromandel got damaged. You can see the effect here on Thames. The flooding of Kaiawa and Miranda down here, the stop banks holding back the Hauraki Plains. But that was a big event. The risk exposure is very large for New Zealand. We have $19 billion of buildings that are exposed to just 1.5 meters of sea level rise. We have 5 airports that are at risk with 1.5 meters of sea level rise. One of those airports is this one in Napier. And you can see here that once you add the vertical land movement in, by 2060, you've got 50 centimeters of sea level rise. And this airport here is already affected by high tide flooding. The extraordinary thing about New Zealand is you only have to go down the coast a few kilometers and you get to a place like Cape Kidnappers or Tiawanga, and there's no vertical land movement. So you're seeing the global average sea level rise. But go figure, isn't this our poster child for sea level rise? Tiawanga gets these massive storm surges that you can see there. And actually it's not due to vertical land movement, it's just exposed to big swell waves. So imagine this on here at Napier Airport in Napier in a couple of decades. Just want to comment on the Indigenous perspective. It's really important in New Zealand, and it's a perspective that matters also for all of us. But I think Māori articulate it very well in their understanding of guardianship, kaitiakitanga, in their stories that tell us their Indigenous knowledge around how the coastline has changed through time. Sea level rise is affecting their marae, their urupā, their communities hugely, and they're aware of it. And the nice thing about Indigenous people, they tend to think on longer timeframes than politicians. And it's really important. If you're going to move an urupā or a marae, it's not just for the next 50, 100 years, it's for the next 300 years, 400 years. So you want to know what sea level rise is going to do if you're going to move that and deal with that and do it once. The community health, the impacts, the stress, the mental health and well-being issues associated with sea level rise are felt strongly, but more strongly in our poorer communities and often Indigenous communities, so this equity issue comes up. So in terms of the impacts of sea level rise, I think the Maori voice is very, very strong, and I think it's helping us in terms of how we should get the best solutions and adapt in a way that will not only be good for a few decades, but for centuries. One of our students, and she's working in an estuary on the East Coast. With sea level rise, we're getting salination of the estuaries and the breeding grounds for inanga. So she's trying to understand with her iwi, Ngāti Kahungunu, how that is affecting the traditional spawning and will affect the kaimoana that is important to them in that region. Now, Alison, if you'll just give me a little bit of time to go into the Pacific, I'll just take a couple of minutes. And I want to make the point that we've talked about New Zealand, but globally, sea level isn't rising evenly. And you can see that on this map here. The red spots are rising at 20 millimeters per year when the global average is only 3.5. This is the Pacific. It's this, it's Southeast Asia. These are areas, small island and developing states, which are being disproportionately affected by the pattern of sea level rise. Of course, President Tong of Kiribati brought this to the United Nations, and the 1.5 target was largely a result of SIDS and what they were fighting for. So there's a huge climate injustice here, that they didn't produce the greenhouse gases, but they're at the front line of climate change, getting impacted by it. And it's complex for the South Pacific. Depending on whether you live on a volcano that is erupting, or you live on an atoll that is sinking, whether you have a fringing reef that protects you, or whether you have really nowhere to go, like Kiribati. And you're not going to go uphill on a volcano that's erupting, and you're going to have landslides as sea level rise. So the risk profiles are very complex for Pacific Islands. But the bottom line is the climate change risks, the drivers, are beyond their boundaries. They're because of us, the developing nations, and the unsustainable use of fossil fuels. We're working with the Ministry for the Environment. We're working for the Ministry for Foreign Affairs and Trade in Kiribati and in the South Pacific, and we're now doing these sea level projections for them. And what you can see here, the red is the bad future, high emissions. The blue or the purple is the 1.5, which is probably not achievable anymore, hence the X. And the black is the best case, I think, we can hope for the Pacific Islands. So you can see, by 2060, and this is above present day, they've got 30, 40 centimeters. And then, you've got higher levels of sea level rise, depending on which climate future we follow. So overall, the impacts are negative on everything, tourism, freshwater fisheries. And I won't dwell on this because I know Philomena is going to get into this. I'm going to flick through this a bit. And James has talked about the effect of ocean acidification on ecosystem services. And really just point out from the IPCC report that, here's an example, flooding, the effect on floodplains affects the soil, the salination of the soil. It affects just takes out communities, it takes out buildings, it destroys, there's a whole bunch of cascading impacts that come from sea level rise alone that propagate all the way through to settlements and infrastructure. And we don't really need to dwell on any of that. So I'm going to finish with some rather sobering last minute thoughts. 30 centimeters can't be avoided. We're in for that, it's baked in. So strap in and deal with it. We should be adapting to that. We can't avoid that no matter how much we mitigate. 50 centimeters is the best we can hope for if we achieve this Paris target by the end of the century, 30 centimeters by 2050. For large parts of Aotearoa, New Zealand, we will be expecting sea level rise twice as fast as the global average. So we've got less time, 10 to 20 years to adapt to that. So we're pretty much, we're in the game, we're committed to major impacts, and the adaptation is hugely important. You will be aware that we have emissions reduction plan for New Zealand, and globally we have to mitigate, but we also have time to adapt. And that's the final message for me, is that there is time. Sea level rise, we've still got a couple of decades to get things in place, even if the mitigation proves a bridge too far. We can't take our foot on the gas there, but in terms of adaptation, we know what's coming. We would be completely irresponsible as leaders of our countries not to adapt to what's coming down the pipeline. Thank you very much.
Kia ora, thank you, Tim. That was extremely sobering. But you have directed us nicely to the Pacific. But just before we go there, everybody remember, throw in your questions, jump into the Q&A tab at the bottom of the screen and ask away. And now, Philomena Nelson. Philomena plays a leading role in climate change adaptation work with SPREP. SPREP works with many small island nations in the Pacific, and as Tim has just alluded to, they are already experiencing the harsh realities of living in a warming world. Philomena, over to you.
Thank you very much, Alison, for that introduction. The James and Tim's presentation is very scary, and that's the picture we're looking at for our small island states.
Yeah, we're not quite sharing full screen yet, Philomena.
Yeah, give me a second.
Perfect.
Okay.
Thank you.
All right, awesome. Okay, so I'm not gonna repeat a lot of it in terms of the impacts, as James and Tim have already covered that very well. But I just wanna touch on one of the key issue for the Pacific region, for the small island states, and that is loss and damage. You know, Tim and James have talked about sea level rise, and there is potential as well for potential to impact on our maritime boundaries, and also the ongoing impacts on our coastlines. And that means that there is potential that we lose our islands. And when we lose our islands, we lose who we are as Pacific Islanders, our cultures, our indigenous knowledge, our traditional ways of doing things, the loss of our biodiversity and the sources of livelihoods that the Pacific people depend on. And as James and Tim referred to, these impacts are already experienced in the small island states in the Pacific. But it's not an easy fix anyway. It's not just about accessing climate finance and then you go away and do things in the islands now, because you need to understand how the Pacific Islands are impacted by climate change. And as Tim referred to, it's different from island to island, because we have atolls, there are also coral islands, and there are also volcanic islands. Some islands are near the equator, some are further away. Some islands, there are only one island, like Nauru. Other countries, other Pacific Island countries, they have multiple atolls spread around, like for the case of Kiribati, or for the case of the Federated States of Micronesia, or the Republic of Marshall Islands. And how we address and respond to climate change impacts, it's also based on our capacity of our governments and our communities in terms of what we know and what we can do, in terms of the financial situation of different countries, and what we depend on, or our source of livelihoods. and also our access to resources. And it's not just about financial resources, it's also about technical resources. There was a question in the chat about electric vehicles. Some of these are already introduced into some of the Pacific Islands. The question is, who can fix this? So it's not an easy fix. You can introduce an electric vehicle, but the question is, how are we going to sustain that? Who's going to fix it if it breaks down? Where are we going to throw all that rubbish when these electric vehicles will be disposed in the long run? So those are some of the challenges that we face with. Climate change also affects men and women, and of course the elderly, the youth, and the disabled. They have different experiences of and how climate change affects them. Men and women are affected differently depending on their cultural and their social roles, their status in communities, and their daily routines. So all these issues needs to be well understood, I guess, across the Pacific Island, by donor countries, by the partners that we work with before, before we actually go into countries to provide support to help them implement adaptation and mitigation projects. I want to focus on what we're doing as the Secretariat or intergovernmental organization in the Pacific mandated to support climate change policy and implementation in the Pacific region. And I'm going to talk briefly about some of the adaptation projects that we are supporting, as well as some of the mitigation projects that we are supporting in the region. One of the projects that we are working with, and this is funded through a partnership with New Zealand through the Ministry of Foreign Affairs, and also with support from the government of Monaco. And it's being implemented through a collaboration between SPRIP, the Secretariat for the Pacific Community, as well as the University of the South Pacific. And this is to address ocean acidification in 3 countries, that's Fiji, Tokelau, as well as Kiribati. And this is to, one of the issue in the region is about data. There's a lot of data out there, but there is no in-country capacity to actually collate, analyze, and tell the story about what this is telling us about our ocean or about our environment or about the impact of climate change, right? So there's this particular project is supporting research and ecosystem monitoring, the collection of data around this to help these particular countries to continue to monitor any changes to the oceans, to the coral reef, to the marine life. In addition to that, there is also support through this particular project to train people in local communities on how to monitor that, how to implement some of the adaptation initiatives that have been introduced under this particular project, and also to talk about it. And as James referred to, it's important that we talk about this, and this particular project is supporting that and encourage that discussion amongst the community of practice within the communities in Fiji, Tokelau, and Kiribati. The other thing is in mainstreaming of ocean acidification or actions to address that across national policies. I mean, we've got the biggest ocean that is surrounding our islands, and we can't afford to leave oceans outside of any policy work that we do. And part of this project is supporting the development of a mainstreaming guideline to help governments as well as local governments and local communities to address ocean acidification through other work that they do. The project is also supporting the establishment of locally managed marine areas, and this helps them with the also their efforts in coral restoration as well. And you can see that one of the pictures there is one of the This is one of the initiatives or one of the tasks under this particular project as part of coral restoration. So it's teaching the kids how, you know, to do this. The other project that I want to talk about is the marine ecosystem-based adaptation project that is being implemented in the big island of Savai'i here in Samoa. And this is to do with, you know, supporting them in rehabilitating some of the degraded mangrove areas and coral reefs and seagrass in 4 villages in the island of Savai'i. It supports them in coral reef restoration and seagrass monitoring, as well as training staff in the Ministry of Natural Resources and Environment that is responsible for addressing these issues, as well as in climate change adaptation assessment. So basically training them so that they have the skill sets and the knowledge to continue to do this work. And also awareness raising in local communities on coastal resource use, which will hopefully help them with their decision making as well. On the mitigation side of the work that our organization is supporting in the Pacific Island countries, we are supporting the installation of biogas systems in 2 rural schools in Ambe and Santo and in Vanuatu. And this is to help generate power and also support organic farming by the 2 schools that we are supporting under the NDC Hub initiative that is funded through EU funding and also with funding support from other partners like our partnership with Irish Aid. You will also note that, you know, there's a lot that can be done, but the amount of money that we're able to access is very small. And a lot of the work that we are doing is at very small to medium scale. And we continue to help the countries to access more funding so that we can scale up some of these initiatives that is helping our communities to cope with climate change and also to reduce any greenhouse gases in their countries. The other big initiative that we are also doing, and this is, it's through the Pacific Climate Change Center, but it's contributing to achieving Samoa's NDC targets or their GHG reduction targets in their NDCs or their nationally determined contributions that they have submitted to the UNFCCC. This is the Pacific Climate Change Center, which is based at our headquarters in Wailima. And it's providing 100% of the electricity that powers up this building is from the solar system, which is located on top of this 2-story building. I just want to, I guess, end my talk, and I'm happy to respond to any questions if anybody's curious enough to find out more. There's a lot of work that we are doing, but you know, I don't have the time to talk about all the things. But one of the things that the Pacific Seeds are asking for in the UNFCCC process is to, we're asking the big emitters to take urgent action to reduce their use of fossil fuels. It's a big ask, but you've seen the presentation from James and team. The future doesn't really look good for the Pacific, given that a lot of our islands are atolls and are low-lying. For the case of Samoa, 70% of our population reside along the coastal area. Now you can imagine, if you noted in the presentation, the projected sea levels, and you can imagine that potentially 70% of our population here in Samoa will have to look elsewhere for a place to live. You know, I've mentioned in the beginning of my presentation the issue of loss and damage, the potential loss of our states, of our islands, and what it means. I mean, as an islander, I wouldn't even want to leave my country to say go and live in New Zealand or in Fiji or in another country or in Australia, you know, and be recognized as a Samoan practicing, you know, my own culture and all of that. I mean, the question is, if we get to migrate to another island, would we be recognized as a sovereign nation? And that's the question that always comes up in our conversations amongst the Pacific Island countries and the UNFCCC process. And it's the main reason why we're fighting in the UNFCCC process to make sure that the big emitters is listening to the concerns that we are raising. And I'll stop there. Uptight.
Apai, thank you very much, Philomena. It's very interesting to, I mean, we hear a lot about what's happening in New Zealand. It is very interesting to hear about what's happening in the Pacific. It's great to see some of the meaningful things that you are doing, and particularly working with kids, I think is very important. Thank you to all our speakers. That's an awful lot to think about. We do have quite a few questions to get through. We have 17 minutes left before our promised cutoff at 8:30. So we're going to do questions with trying to keep the answers a bit short. I know that's really challenging. I know these are complicated questions, but let's see how we go so we can get through some of them. The first question is for you, James. It's from Elvisa van der Leiden. Do you think the emissions trading scheme is an effective tool to tackle climate change, and to what degree?
That is an interesting question. It's part of the mix, I would say. An emissions trading scheme by itself doesn't solve all the problems. What it does really is put a price on carbon. So it pushes emitters, businesses basically to carry out their business in lower carbon ways. But it's just a tool. You need to have some kind of legislative direction as well from the government to sort of steer the country to where we want to go. It helps things, but it doesn't solve everything. So it's at what proportion of the solution is the emissions trading scheme? I'm not entirely sure, but maybe a third or so. And you know, not every part of the economy is part of the emissions trading scheme, so it doesn't cover everything. So it's a good thing to have, but we need a lot more than that.
Fair enough, thank you. A question for Tim. Helen O'Deely asks, do rising sea temperatures affect the weather?
Right, well, James could answer that equally as well as I could, but there has been some interesting stuff happening lately that you might have heard about, and these are these atmospheric rivers or heat waves. So I guess, you know, what we've been seeing during our summer, you had a period in January where we had some incredibly humid weather, and that was largely due to the ocean warming and from the subtropics and coming down towards New Zealand, and the atmospheric circulation, you know, sort of focusing this moist air from the subtropics onto New Zealand. And now you might have heard about this Antarctic heat wave that occurred as well. And again, that is thought to have originated south of Australia due to the amount of heat that was in the ocean and the atmosphere, and it was directed down over a part of Antarctica, and they saw these incredible increases in temperature and melting around the coast of Antarctica, particularly East Antarctica. So absolutely, you know, James and I might argue over the relative influence of the ocean versus the atmosphere, but it's the atmosphere that moves the atmospheric heat around for sure. But the fact that the ocean currents are bringing this warm, this, as James talked about with the heat waves, this warm air south to regions like Fiordland that just don't expect to have those sort of temperatures is a really concerning sign.
Am I right in thinking that warmer water in the Northern Hemisphere in particular increases the intensity of some of the hurricanes they're having? Because there's more energy in the system.
Yeah.
Yes, absolutely. And especially for hurricanes, tropical cyclones, they get their energy directly from the ocean surface. The warmer the water, the more energy there is in the hurricane or the cyclone. So yes, generally speaking, we're adding heat to the climate system. We're adding fuel to storms, basically. So we expect to see stronger storms generally around the world.
While we've got you, James, Ella W has asked, what effect does changing ocean temperatures have on ocean currents?
Ocean currents, Ella, that's another great question. And the way currents flow, both near the surface of the ocean, but right down to the depths of the ocean, depends on the differences in temperature and in salinity in the salt content of water, different water masses. So the oceans are not, just like sea levels are not rising equally everywhere, air temperatures are not rising equally everywhere, the ocean is not warming equally everywhere. So we're changing these temperature differences around the ocean. And so that changes the forces on water. And so that changes the way water moves. So I would say it's quite hard to say, especially for the deeper ocean circulation, how that's all going to play out. But for the upper ocean, we can certainly see changes in the strength of some of the surface currents to do with changes in temperature differences across those currents and so on. So there are effects, and actually one of the important effects is in the vertical motion in the water. We're changing the vertical differences in temperature, and that changes the ability of the water to move up and down, which can have really big effects on marine life. We get these so-called dead zones where we just don't get ventilation of the water down to depth because the overturning stops and we run out of oxygen, basically. So it's a really big deal how the change in temperature changes the flow of ocean water.
Now, Philomena, are you there? I have a question for you. Another one from Alviza, which is it's an interesting question. Humans have a history of domesticating species, selective breeding, etc., for the sake of saving local biodiversity in the changing climate and marine environment. Is there an element of selective breeding when it comes to climate resilient marine species? As I think the question is that an aspect that we might have to call on perhaps gene editing even in the future to speed things along, to make species speed up the rate of evolution? Because one of the big things I've heard tonight is the speed with which things are happening, and it's the speed with which things can adapt is a real challenge.
Yeah, that's correct, and thank you for asking that question. These are all the things that are being considered. It's not about just regenerating, but also look into what can live in those environments in the islands. Yeah. So it's very much part of the work that is being undertaken by the Secretariat together with its partners to look into what can live or what can grow in the different environments across the Pacific Island countries.
Thank you. And we'll keep you here. Leslie Bolton Ritchie asks, is there any work being carried out on mangroves in Kiribati? From your talk about Samoa undertaking work on mangroves, she thought, well, I know there are mangroves in Kiribati because I live there. Do you know whether they're looking at mangroves there as well?
Yeah, I think I've already typed in a response to that, but Maori, Leslie, yes, correct. We have another technical program that focuses on islands and oceans ecosystem. And they do that work in Kiribati for our climate change resilience program that I work for. We are implementing the ocean acidification project in Kiribati. A lot of the priority from Kiribati in terms of their adaptation priorities, a lot of it focuses on water security. It's a big issue in Kiribati and the outer islands. So the bulk of the work that we do there also focuses on water security as well. But yes, the other technical program of the Secretariat focuses on that.
Very interesting, thank you. Now there's a couple of questions from a couple of listeners. Elviza and John have basically asked questions about young people, youth and children even. What could or should their roles be in climate change and knowing about it and about advocating for countries that are suffering from it? How do we get coming generations more involved, and how do we make it so that they can call the shots a bit better? I'd be interested in a thought from each of you. I'll start with you, James.
Yeah, that's another great question. First thing I would say is lower the voting age to 16. That would be a great thing to do. I think young people, sad to say, it's another inequity. You know, it's people like me, my generation, that have caused a lot of the problems, but it's people, students who are at schools now, who are the ones who are going to live through a lot of the consequences. So younger people today are going to have to bear the burden of the changes in climate by and large. And my experience is that a lot of young people are pretty engaged and pretty fired up. You know, the school strike movement and all the activism with 350.org and Generation Zero and so on. I meet a lot of young people who are very active in that space, and I just urge anyone who's interested to contact one of these organisations and just start to take some action. So yeah, I think giving younger people more say in things is a really important thing to do.
Tim.
Yeah, it's something I think about a lot and I worry about because my children are at that age, and I talk to them about it. My sense is there's a lot of angst out there around the world that they're heading into, whether it's climate change, the political instability in Europe with Ukraine. It's tough being young at the moment and feeling like, you know, they look at us and go, well, you guys had it pretty sweet, and now we're inheriting this world with all these issues. So I think from a communication point of view, and James touched on it, is, you know, we have to empower young people. We have to give them a sense, and I worry that even tonight we've said a lot of negative things, it's all bad, but there are some really positive messaging, and not that we need to sugarcoat it, but the problem can still be solved, and young people are super critical. And they will, as James says, that will be there. They will have to solve the problem, but it's an exciting future. And if we get it right, the opportunities, you know, are really huge. So we need our young people to be engaged, to be part of the solution, but not to be frightened by it, but to see the opportunities that come from a world which is more sustainable, from a world that is healthier, from a world where we're nicer to each other. And you know, I mean, I just hope, and I do have great faith, that young people are seeing that side of things and are going to redress some of the things that we really messed up.
Philomena, what do you think about kids? You talked a bit about involving children and youth in some of the work you're already doing.
Yeah. Thanks, Alison. Yes. In addition to what's already being mentioned by James and Tim, through the work of the Secretariat, because we also support the Pacific Island countries, you know, to prepare them for the UNFCCC negotiations. And that's in addition to the work that we are already doing.
Oops, you've just frozen. Are you still there with us, Philomena? I think we're having an internet issue. Can you hear us at all? We can't hear you anymore. I'm very sorry. I will keep moving on. Hopefully Philomena will come back in a minute or two. In the meantime, I might start drawing this to a close. I do have a final question, which is what can we, as general members of the public, do to help slow down climate change and actively remove greenhouse gases that are already in the atmosphere? James and Tim, you can fight over who's going to be first. Philomena, I just asked a question about what can we do as members of the public. I'm sorry we lost you before for a couple of minutes.
Yeah, I know I dropped off, and I just want to finish off my response is that
please do.
We are also working with Pacific Youth Networks, like mentioned by Tim, the 350 org. I'm pretty sure you've seen Brianna Fruin, who's our former youth champion for climate change. And we are just re-engaging her as well and some of her members of the network to support advocacy or Pacific advocacy on climate change in the lead up to COP27. Just the last point. I mean, we can't just say that our youth, our children will have to deal with this problem in the future. Of course they will have to. However, we need to engage them now in the conversation, in the work that we are doing. And it's great to see a lot of interest from the young ones in looking at solutions to address a number of issues that is causing climate change, or a number of issues that we need to consider in how we adapt to the impacts of climate change in our islands. Thank you, Alison.
Thank you. Thanks for coming back online to tell us that. Very quickly around the table, one thing from each of you. We've already touched on some of them. James gave us the list at the end of his presentation. What can we as general members of the public do? One thing, starting with you, James.
Talk about it. Write to your MP, make a noise.
Tim.
I have to agree with James. Right now, it's about our leadership. We've got to get the right leadership. Write to your MP, vote for the right party that's going to deliver the solutions. But I'm going to have two here, Alison.
Oh, all right.
But you know, there's some really simple things. You know, public transport, biking, walking, get healthy as well. That's a co-benefit. And you know, for New Zealand, the electrification of the vehicle fleet is a no-brainer. So we just have to make it available and equitable to all people. But there are things we can do at home as well. Yeah. But if we don't have the right governments in charge, oh my goodness, we could slip. And we're at such an exciting place in New Zealand where this could stick for generations to come, and we just need to make sure it does.
Ka pai. Philomena.
From me, Alison, similar to James and Tim, talk about it, make a lot of noise about it. We depend on New Zealand to make that noise because the Pacific needs you to make that noise so that we, you know, continue as the Pacific Islands, as the Pacific region into the future. Otherwise, we'll be gone forever.
Yep.
Yep, indeed. Thank you, everybody. A huge thank you to James, Tim, and Philomena for challenging, confronting, interesting, eye-opening presentations. To you, our audience, thanks so much for being here with us and asking such great questions. I'm very sorry if we ran out of time before we got to your question. Kia ora and many thanks as always to Sarah, who is working away behind the scenes, making this all happen for us. Big shout out to Sarah. If you could take a moment, please, to fill out our survey, which we've just posted in the chat. We will also send out a follow-up email, which will have this link, because we would love to hear what you thought about tonight's webinar, so we can make the next ones even better. If you missed our previous webinars, they are all online. You can share tonight's one will be up in a couple of days. You can find them all on the CWeek website via the resources tab, as well as on the CWeek's YouTube channel, or on the Facebook page under the videos section. The next webinar is on the 28th of July. Put it in your diary right now. It will shine a spotlight on the many ways in which mātauranga Māori is significant in the marine conservation realm. A karakia to close. Ono hia, ono hia, ono hia ki te oru tapunui. Kia wātia, kia mama, te nako, te tinana. Te waroa, te araka tākata, koia rā e rongo, whakaeria akire kei ronga, kia tina, tina, hui e, taiki e. Thanks for your company, everybody. Ata Mārie, good night. Stay safe. See you next time.
Thanks, Alison.